In this video, we are going to study how a spectrum analyzer can be used as a radio receiver. If we look at the spectrum analyzer basic block diagram, you will see this one is from a Hewlett-Packard app note. There's numerous components that remind us of the AM receiver. Here's our AM receiver block diagram, where we have the RF signal coming into the system. It is mixed with a local oscillator signal, put through an IF filter and amplifier system, and then detected. And of course, audio comes after that. If we go back to the block diagram of the spectrum analyzer, we have an RF signal. Now we're going to have a broadband signal, not a single frequency, a mixer, and a VTO or voltage tuned oscillator. This device is very similar to the VCO or voltage controlled oscillator that we talk about in FM. The VTO signal mixes with the input RF signal to go through the RF filter and amplifiers, and the output is detected as an amplitude and sent to the Y display of an XY system. At the same time the VCO signal is being changed in frequency, we are sending a synchronizing signal to the X axis. So as the signal changes frequency here, the trace will also move on the X axis. So now we get a amplitude versus frequency display through this system. Now the AM radio, we left the local oscillator at one frequency to get one signal converted to FIF. But in the spectrum analyzer, I'm going to change the mixed signal, or at least the local oscillator type signal, so I'm going to get a range of frequencies to be displayed. To use the spectrum analyzer as a radio receiver, after we've turned on the spectrum analyzer, I'll simulate that by pressing the preset button. The spectrum analyzer comes up in its normal mode. So we first need to attach an antenna to the input to the device. Now in this case I'm just starting out as a set of clip leads as an antenna. Now if I do that, you'll notice immediately you start to see signals pop up on the spectrum analyzer. Particularly you'll notice this one down here. Even if I touch the leads, you'll notice that that signal gets bigger. Antennas are very sophisticated and very touchy devices, and so they're very subject to physical setup and physical manipulation. So we're going to change to a set antenna, but any wire can potentially be an antenna. You just may not get enough signal to detect much. The second thing we have to do is we have to have a speaker output. So we take the output, the 3.5 millimeter stereo jack out of this speaker, plug it into the headphone input to the spectrum analyzer. Now I'm going to change my antenna on my spectrum analyzer from this test lead to a little bit more formal FM antenna. The antenna I've got connected, and you can see how much larger the signal gets. The antenna I have is an old-fashioned television type antenna. They used to call it a rabbit ears because you could spread the two components, the two pieces of the antenna apart, and you had to do that many times to get the best signal. I've also got a device between the antenna and the spectrum analyzer called a balun, B-A-L-U-N. That means balanced to unbalanced. So the antenna is a balanced signal, meaning there's no ground associated with that, and this balun is an RF transformer that converts to an unbalanced system or grounded system. Very important for matching impedances also. And we get a pretty good signal on our spectrum analyzer. Now, we don't see much except in this band in here, and that turns out to be the FM band, which is 88 to 108 megahertz. So we're going to set the frequency for that band by hitting frequency 98 megahertz, and then span we will set at 20 megahertz. Now you could also set the start and stop frequencies at 88 megahertz and 108 megahertz, the same thing. Now when we look at the display, we see several different signals, right? I'll adjust the resolution bandwidth so we can get them a little more finely picked out. And we see a number of FM carriers popping up. I recorded some of them. The peak signal occurs at 98.3. That happens to be the antenna on the hill outside of Cal Poly, and that red and white antenna outside the window. And that's 98.3. The next channel, there's a 97.5, a 99.1, and a 99.9. FM signals are 200 kilohertz in bandwidth, and they're spaced every 400 kilohertz so that they don't interfere with each other. That's by FCC rule. Now we need to set the frequency to that peak signal. So that's 98.3 megahertz, and now it is directly in the center. Now we need next to set the span to be zero span. We have never done that before, but essentially that's a demodulating span, and that's the actual signal being demodulated. Now you don't hear anything. For one thing, I haven't got my speaker on, so I'll turn the speaker on. Okay, you still don't hear anything because we haven't turned the demodulation on. So hit the demod button and then demod on and FM. Now we need to then set the demod setup here, and the demod setup you have to turn the earphone on. That turns on this port down here, and then you can hear the signal changing, that clicking. That's because of the demod time is 100 milliseconds or 10 times a second. Set that demod time to be 10 seconds and it will sound more normal. And then we hear the signal, the FM channel. I can confirm that value by adjusting my radio here that I've got in the lab to 98.3. Alright, so we set the channel to 98.3 megahertz, right? Did all the demod functions, demod FM, set the time, the earphone on in 10 seconds, right? And we hear the audio. And we can confirm that on another radio by going, here's my little handheld radio or carryable radio. And we get 98.3 and the sound. And of course they are the same. Alright, so now we can check another channel. 97.5 was another frequency. So we'll type in 97.5 megahertz and see if we get a good download here. And we get that channel. So we'll change to 97.5. Turn up the volume here. Right? So then we hear the music. Right? And of course it goes on, and 99.1 was the next frequency. We can't get all channels, but like I said, it takes 10 seconds for this to recycle, and you'll hear it change. Not as good a signal there, a little smaller. So we'll go up to 99.1 here.
I can do with it?
No, what?
I can unlock it with my face. They call it Face ID. Check it out.
So that channel did not come in as well, but you get the idea of how we're demodulating. So that's the simple process of using the Spectrum Analyzer as a radio receiver. Set on the frequency, set the span to 0, and then you just go through the process, AM or FM. These notes will be in, I'll post these. This is, if you get lost or don't remember some steps, you can always go to the Rigol user guide. In this case, I looked for demodulation, and then there's a couple pages on how to do demodulation. It's very straightforward, only a couple pages there. The Spectrum Analyzer block diagram is quite important because it has application both as a radio receiver and as a spectrum analyzer.